Okay, I have my tool here for working with steel cutting. I took measurements from the Powerwall, how this has to look like. So we're going just to cut these pieces, and this one here is for my pushing plate. I have to make a cut the length of that piece of steel, and after cutting the parts we will then weld it together. All the bits are cut, so now I'm going to get my welder and weld this together. Okay, the side part is finished now, and now we're going to the Powerwall and weld together all the rest of the pieces. Yeah, so the metal works is done, and I already prepared the door, but I will not put it in yet. So we have time, it's just lunchtime at the moment, so it's enough time to also put the cells in today and connect bus bars and cables, and so later on we will have a much bigger battery pack running our system today. Okay, let me show you what I did with the battery cells in the meantime, and then we are going to populate this new shelf. This is now kind of the status after equalizing, but equalizing, I must tell you, did not really work out well. There was still, you see here, I still have cells 3.33 volts, and I also have a group with low voltage. So actually the group of low voltage cells have been much bigger, so I took some and charged them up into the middle group here with the DC power supply. So I have now 5 very low, 5 very high, and then I have the middle group. So the plan is now, of course, take always the lowest voltage and the highest voltage cell, and they will be married together in one of the existing cell groups of 3, and yeah, so it will actually even out then. But still, we will then see the state of balance just after charging the pack then for the first time. Okay, so I'm going to pack all these cells and bring them to the new shelf, and then we are going to build the pack. I've stopped charging my pack at around 35% today, because that should now equal a cell voltage of around this 3.29 or something like that. Yeah, so we have exactly 3.29 volts on these cells here, and that is the average voltage I have prepared for my new ones. So they can be mixed now into the other cell groups quite easily. I will now disassemble this, and then I have prepared my new bus bars. So these are the bus bars which are spanning 10 cells, the serial connections then. Here from the other ones, which have 6 now, 6 holes, I will take those, cut one of the holes off, and I will use those on the sides where I need 5. Let's remove all the bolts, and yeah, then as I said, the strings will remain the same cells. I will just add 2 of the other ones. First I'm going to unplug the BMS. Later on, I'm not sure if these BMS sensing leads are long enough, so we will see that. The BMS will be situated here, right after these 5 cells here in the middle, so it should be quite a central place, but I still don't really know if these wires are long enough. This pack here with all the bus bars on this same terminals, and now for 1.5 years. There's actually, I'm using aluminium, and these terminals are also aluminium, and looks like even some nickel plated on one side, and there's absolutely no corrosion on this. So for everybody who is using copper on aluminium, it is known that it will cause corrosion by time, but these ones here, absolutely nothing. These here are the 3 cells of string number 4. String number 4 always had a little bit a performance problem, and I took them apart, and right away, after maybe now for about 20 minutes, one of the 3 cells immediately dropped the voltage lower than the other one. So these ones here, these 2 are 3.29 volts, and this one 3.27, and this tells me I'm going to replace this cell here with my spare cell, and I think we are going to then get rid of our problem within this cell group here. First row is done. We have now here 3 strings of 5 cells in parallel. Here will be the battery minus, cell group 1, 2, 3, and we are continuing now in this area. 4, 5, 6, then 7, 8, 9, 10, and then jumping back on the lower row, 11, 12, 13, 14, 15, 16, and here will be the BMS, so this will be kind of central. Okay, I will continue to do this here now, and then I will show you when everything is finished. Okay, here we are. It's done so far, and the cells are also fixed in place. As you see here, we have our screw rods everywhere, and actually they are not really compressed much, because I have prepared the bus bars for 4.3 centimeters distance between the cells, and originally when they're brand new they are 4 centimeters wide. So I'm allowing about 3 millimeters of expansion, and this is what they have when they are like this now. So they will be held in place. When they are charged they will probably expand a little bit, and this will be prevented by the screw rods. Yeah, looks really great. Look at these 2 full shelves now, and yeah, we are going to continue now, and I will put the bus bars and connect everything in serial strings. What I'm using is actually regular bolts, and I use 1 nut here. So I'm screwing the bolt into the terminal as far it is more or less possible, and then the rest is then just adjusted by the nut. So the bolt is more or less doing a job of a stud. Then I have a big washer, and this is just holding the bus bar onto the cell. I don't use any force here, just very carefully turning the screws and bolts by hand, and then at the end the nut will be just tightened with a tool. It's getting late again. It takes so long to put all these bolts and bus bars. Anyway, I have to adjust the cables here from the BMS to bring it back over here, and then I have to check about the balancing leads. So anyway, so I will stop the work for today and continue tomorrow morning, and will then just show you when everything is finished. The next day in the morning I have connected all bus bars, and I also connected already the balancing wires of the BMS. And before I connect now those balancing wires, I have to check if everything is connected correctly. So I'm going to measure all voltages now on this small connector and see if the steps are correct. 3.29, 6.58. 49 and total 52.7. All the cell balancing wires are connected correctly, and I'm going to plug in now this into the BMS. Okay, the connector is plugged in. Now I want to check if we have power on our main circuit breaker. And yes, the power is switched through the BMS and we have power on the main circuit breaker. So I'm going to open it and see if we have again all the power in our electronics compartment. Right, the moment of truth. Let's power up the system. Main breaker is on. Controller on. The controller is powered via the DC from the battery. It's in the startup sequence now. Okay, so let's see what the battery voltage is saying. 52.55. Yeah, okay, we have power again. The battery size is now much bigger. I have to reprogram this into the controller to tell it how big the battery now is approximately, so that it can adjust on the new situation. Now, as we have a bigger capacity, we of course need also more energy to be put into the batteries, because these two chargers of course not strong enough, not powerful enough to fill up such a big battery now. So this will be the next. We have to add another charger, so this will require some more wiring and additional breakers, etc. That will be then the step 2 in our upgrade, and there is further steps to come. So please bear with me. Thank you for watching this episode. Please comment, subscribe, like the video, and I see you next time.